Here's the overall chiller array on the test stand with the factory in the background. We'll move in on the C1 panel. In the lower left you can see the blue convenience outlet. This is the connection point to the remote panel. It also has a remote and local override switch. Moving left, we see the single point power junction box. This is the single point that distributes power to all of the mechanical modules, the pump module, and the heat exchanger controls. This is the entering connection through a dual basket strainer from the comfort cooling loop, as well as the piping connection that runs back to the comfort cooling loop. You also notice the 3 Belimo actuators, valve 1, valve 2, and valve 3. Now we'll give you a tour of the operation of those 3 valves. Water comes in cold from the comfort cooling loop and can bypass and head back to that loop if it is not cold enough to provide cooling. As another option, water can come in. If the bypass valve is closed, water will go around and, as I am showing, go through the heat exchanger, exit through valve 1 here, and then return to the building. In that final loop, it was providing cooling through the heat exchanger to the load. These 2 valves would be open in the load situation, and the middle valve would be closed. The middle valve opens and the other valves close in bypass. This is video showing the identification of an issue with the indicator lights on the heat exchanger control panel. This issue was resolved before the end of the factory testing day. Now we'll show video of the testing and how it was proven to work after resolution. The temperature sensors are in an ice bath, which tells the controller that the building comfort loop is providing sufficient chilled water for the heat exchanger to do work, benefiting the space. You'll notice that the indicator lights have switched the position of the 3 valves. The middle valve in bypass and the isolation valves for the heat exchanger open. Now we pull the temperature probes out and warm them up, again simulating now warm water coming from the comfort loop. This will cause the indicator lights to flip, where the bypass valve will go open, that's the middle valve, and the 2 isolation valves for the heat exchanger will go closed. And you'll see that here in just a second. You'll also notice that the bottom indicator light is red, that it is off. These are stub pieces that are shipping loose with probes for thermometers, pressure gauges, and sensors. This is the 160-gallon storage tank with the bypass connection. Water comes in through the tank, out of the bottom of the tank, and then over into the pump suction. The normal path is for water to go through the heat exchanger, but you can see there's also a set of isolation valves to isolate the heat exchanger and open a bypass path. You can see the primary and backup pump in their stainless steel housings in the background. Moving right to left through the auxiliary module. This is one of the mechanical modules. We'll move in and around and get a close-up view of some of the internal components within each module. This is the overall leaving connection from the chiller, the lower of the 2 headers on the left-hand side. It's a close-up of one of the 2 receivers in the rear module, another receiver, and the chilled water headers. Now we'll get up inside of the chiller array to give you a little bit more of a close-up view. Compressor 1, compressor 2, one of the liquid line solenoid valves, isolation valve, which is on both the top and bottom water connection to the braze plate evaporator, and now you can see the 2 receivers off to the right hand side, 1 and 2, and that's because this chiller utilizes independent refrigerant circuits. Those are the high pressure switches for circuit A and circuit B. Now we've moved into the next mechanical module, and you can see the similar setup. That is the cover that will go on top of the dual basket strainer when it's in operation. And now we'll pan around to the front of the array, seeing Module 1 and Module 2. Power comes in on the right-hand side of the cabinet and works its way right to left through a power distribution block, breakers for control power, the 2 condenser fans, and the 2 compressors. In the lower part of that breaker stack is the power phase monitor. You can see the VFDs for the condenser fans and the manual off auto switch in this close-up view. And now we'll look at the lower components. You see a low pressure and high pressure gauge for each circuit. Again, there are 2 of them since this is an independent circuit chiller. You can see the liquid line filter dryer for circuit 1 and circuit 2, the evaporator in the background with the receiver on each side. And now panning back to see the front of the array. And down on the left you can see the pump module. As we move down toward the pump module, we'll see the remote panel. Again, this is mounted in the space, and its interface point on the array is the C1 panel. You can see various LED lights, the pump 1, pump 2 start-stop, the heat exchanger enabled indicator, and the remote display itself, which is a mimic of the master controller. And now for a tour of the pump cabinet. Again, power comes in and works its way right to left. You can see the control circuit breaker on top, the 2-pole breaker, and then 2 individual 3-pole breakers for pump 1 and pump 2. That was a close-up of the power phase monitor. The contactors for the pump, this is a close-up of the ABB timer, which rotates lead lag pump operation. The on-off reset and placing pump 1 or pump 2 in lead switch. And these 2 timers are used with our DP switch to allow 5 seconds, as they are currently set up, for the DP to be proved. The 2 gold valves there are both working toward the low side of the DP switches. You can see 2 of the DP switches there, and then the other hoses are going to the high side. Again, we have redundant differential pressure switches, and those are utilized to indicate pump failure and switch from the lead pump to the backup pump. You can see the heat exchanger and the automated control valves in the background, the lead and backup pump, a close-up of the price pump model number. And this is the path coming over from the tank, splitting into the pumps, and then the discharge up and over into the top header of the chiller. Since refrigerant evaporates up to get heat exchange counterflow, the water flows from the top header into the bottom header. Now we're showing the path from the expansion tank and the glycol mini feeder into the system.